Good afternoon, everyone. How's everyone doing? Come on, give me some energy. It's 5 p.m. and I'm the only thing that stands between you and the chain smokers tonight. So trust me, buckle up, roll up your sleeves. We're going to have a lot of fun together, and I'm going to give you the best of my energy. Sound good? As long as I get a return, okay. So I'm Lachlan Evenson, and this is the honest practitioner's take on Agentic AI on Kubernetes. Say that 3 times quickly. Now, today, I'll be your honest practitioner. I have had the luxury of working in Kubernetes for over 10 years. Anybody else using Kubernetes in the room? By show of hands? Excellent, excellent. All right, you're in the right place and it's the right time, because this session is for people already running Kubernetes who are trying to figure out what AI workloads actually need on top of Kubernetes. Who's running AI on top of Kubernetes? No one yet. Okay, trust me. By the end of the session, 45 minutes, come to me if you don't have something to walk away with, okay? So what we're going to cover today is what works today, what's harder than it looks, and where the ecosystem is going, right? All on your journey to Agentic AI on top of Kubernetes. That sound good? With me? All right, let's do it. Okay, our agenda, we have 3 parts for this agenda today, and trust me, I had a lot of fun working on this deck, so if my excitement doesn't come across already, I'd be surprised. But I've had a lot of fun over the last few months working with agentic systems on top of Kubernetes, and I think back to 10 years ago when I started in Kubernetes, I had a lot of excitement. I had that aha moment when I first ran a container in production, and I scaled that out to 100 containers. Anybody have that aha moment with Kubernetes? I had that same feeling with agentic AI systems running on Kubernetes. And my kids were watching Willy Wonka the other day, and there's this scene where 𝗦𝗽𝗀𝗻𝐶𝗿𝗄𝗎 sings "In a World of Pure Imagination." I feel like for the last 10 years, I've been trying to build platforms, and now I get to go back to the world of pure imagination and create really cool systems using agentic systems on top of Kubernetes. So hopefully with this journey, I can impart some wisdom within you all to go on your own journey, and I'm going to make it very tactile. We're going to see demos, customer cases, and you're going to get access to some Kubernetes repos that you can take away with you. So let me go through the 3 parts of this agenda. We're going to go over why Kubernetes shows up as a substrate for running the biggest AI workloads in production, and what managed stacks are great for, and what self-managed stacks, like running on top of Kubernetes with your agentic system and your AI workloads, are great for some teams. What it actually takes to run AI in Kubernetes and AKS, we're going to go layer by layer from inference to serving to training to agentic systems. So we're going to walk the stack together, okay? We're going to go through the whole lot. Third, we're going to take a look at what this looks like in practice with real customers and real workloads. So we're going to work you through some sovereign customers, some financial service customers, how they're leveraging the platforms and tools I'm talking about today to power their AI workloads. And as I said, we're going to walk away. You're going to have a checklist that you're going to be able to take back to your team this week. I always say, when you go to a Taylor Swift concert, what do you want? You want something you can't get on TV, right? I'm going to give you the stuff that you don't get on TV in this audience. Splash zone, beware. So you're going to get wet in those first 3 rows, okay? Okay, let's go ahead. Let's dive in. We need to start with the why. I can't tell you the what without giving you the why. I think the why is so important as to why we're doing these things, right? So let's start with the why, and then I'll get to the what and the how, okay? But it's important to be honest up front. This is the honest practitioner. I'm your honest practitioner for today. Kubernetes is a big hammer, and with a big hammer, everything looks like a nail. Kubernetes isn't always the right fit, but in some cases, it is the right fit. And in the case of scale, AI and scale run hand in hand. Kubernetes is a great platform to be able to run AI at scale, and it certainly is one of the right answers in that. Okay, so we want to actually go through the why and why that scales and why it matters. I think it's important to start with looking at PaaSes. When you're on your journey, you start with PaaSes. On the left there, we have full managed AI services. The session before this was about Microsoft Foundry. That is an example of a fully integrated AI platform. And then over on the right, we have AKS and Kubernetes, right? And what we're going to look is the left side provides a managed AI platform, which is going to be your fastest path to a deployment model, right? It's curated, it's standardized, it's vendor choose. On the right side, in contrast, Kubernetes is a deeper path into the stack. It's composable, it's open, and it's U-tuned. I think the open is really powerful because if you're running in multi-cloud, if you're running on-prem, if you're running in sovereign, the open allows you to run Kubernetes in those environments as well and have a very similar experience, right? But we are composable and U-tuned. Neither end of this scale is wrong. It's a matter of where your team sits, right? There are common patterns for speed and deployment. You might want to be on the left side, and Foundry is probably your answer to take those common patterns. If you want extreme scale, tunable, tight cost control, data sovereignty, or building something, a managed stack that doesn't allow you to quite tune, you might need a composable substrate, and AKS and Kubernetes might be the right choice for you. So if you're working with Kubernetes, as I saw a few hands in the room, Kubernetes and AKS may be a great place to start or might be the right choice for you. Okay, but I think it's important to see the trade-offs between fully managed and integrated paths to composable substrate. And I'm going to pull on that a lot throughout this session. All right, I love iron triangle of project management. You have the three things, the fast, the good, and the cheap, and you get to pick two. Doesn't that feel like a trade-off? Well, the iron triangle is full of trade-offs, so AI kind of has its own version of this trade-off as well, right? So AI has quality, speed, and cost at each apex of the triangle. So let's take a look at how you can leverage those different sides of the triangle with these four different controls. So we have granular control, which allows for the quality, right? You get to choose your scheduler, accelerators, you get to choose the isolation model for whatever your customers need. Open tooling, I think, is super important. The open tooling ecosystem and the fact that Kubernetes and AKS leverage the open ecosystem gives you value of the whole AI open source stack without vendor lock-in. As I said, you can run this on-prem, you can run this in other data centers, you can run it in other clouds and have a very similar experience, and that may be important to you. Data sovereignty, I think this is a big critical time, talked about a lot with our customers. Workloads, data, and weights stay where the compliance demands. You don't have to send them off premises. You can keep them where you're comfortable within your security boundaries and confines. And visitor unit economics. The talk of the town is cost per token, right? We all worry about cost per token. With a self-hosted platform, you can actually tune your cost per token, cost per inference, cost per tenant, and it's all tunable. So you have control over the cost. The data stays with you. You're relying on open tooling, and you have granular control. The trade-off of all this, and there's always a trade-off at the bottom, you can see is complexity. So you're buying flexibility with operational overhead. So this platform will give you ultimate flexibility, but you need to operate it. And don't worry, AI agentic systems can help with that too. We'll talk about that a little later. Okay, so if this is you, the composability isn't optional, it's required, right? So here are the profiles we see on the left in blue of where self-managing wins and where we see our customers selecting self-managing. Teams running AI at scale with cost or sensitivity to where the data is sitting, ISVs and cloud agnostic vendors who are out there building and shipping AI platforms to on-prem and edge, and platform owners who want composability rather than rent. And then finally, if we look on the right, here are the primitives doing the work. So the great thing about Kubernetes is it comes with all of these things out of the box to manage the substrate. We have declarative resource management where we can manage memory, GPUs, quotas, defined as code, everything's declarative. We have heterogeneous scheduling in a world of a lot of different accelerators. You want to match the right workload to the right accelerator at the right time, so we can compose heterogeneous clusters with different types of accelerators, networking accelerators too. We have namespace isolation, where we can have multi-tenant AI not crossing that security boundary within Kubernetes or having to rewrite your security tools. And then finally, there's a complete ecosystem full of primitives built with this. I see Mark in the back, 𝗲𝗲, right? Lives on top of, he gave me a wave. He works on a project called 𝗲𝗲, which sits on top of Kubernetes, but these abstractions are durable and something that these other platforms can build on top of to be able to have great experiences. So you can build your own platform. So Kubernetes obviously handles the complexity. It's built for that complexity, but not in spite of it. So far, so good. I'm going to go grab some water, but as I just frame this up so you can take a look, AI comes in three different, very distinct workloads. On the left in red, we have inference. In the middle, we have training, and on the right, we have agentic systems. The purpose of this slide is actually to identify that each workload has different conditions, different lifetimes, different compute. So there is an operational environment that's required for each of these different workloads. So let's take a look at them quickly. But take a look at inference, start at inference on the left here. So lifetime, milliseconds to seconds per request. We have both GPU and CPU in the mix, so heterogeneous, often single node. You can run inference on a single node. When we talk about training, that's not often true. And the failure mode is just drop the request. And the cost vector here is what you need to optimize on is latency and cost per token. And down the bottom, what we're going to get to is different open source tools and platforms. So we have Kaito and AI Runway there as places that you can leverage inference on top of Kubernetes and AKS. Training is throughput bound, right? Hours, weeks. Data scientists get really mad when their training jobs break because they have to resume from a checkpoint. And when you're utilizing extremely expensive hardware, time is money, and every minute on those compute platforms is money. So you want to make sure they're absolutely saturated and absolutely utilized to the full extent. And you want throughput, iteration time. How long does a training iteration take? That's the measure. We're going to discuss Ray and AnyScale on Azure as solutions to help you with the training, which is throughput bound. And then finally, we're going to talk about some agentic systems, but sessions, minutes per turn, right? We have autonomous agents, autopilot agents running on our behalf, ingesting data, making decisions, and helping us get through our day. They're multimodal. They take input from images, text, voice, video streams. They resume on state and mid-session, so we need some kind of state awareness. And tool call latency is obviously very sensitive. What tools they need to call to ultimately get you the response that you need. And down the bottom, we're going to talk about skills, MCP, and a platform called OpenClaw, which I heard has been talked about a lot today. So they all share GPUs, but these three discrete workloads for AI do not share the same operational assumptions. With me so far? Okay, I'm talking quick, but hopefully can bring it along. Okay, excellent, thank you. Thanks for the nods, in agreement. Okay, so Kubernetes gives you the foundation, but AI, the era of AI, asks for more on top. So Kubernetes is necessary, but it's not sufficient at the moment. You need more on top of Kubernetes, and you need to be able to build a platform that enables AI workloads on top of Kubernetes. So there are some gaps that Kubernetes needs to close, right? And these gaps are being worked on. But for example, we took at the top left. Traditionally, Kubernetes has workloads that can be scheduled one pod at a time. AI workloads want hundreds of thousands, tens of thousands of pods to start together, right? So you need to use things like gang scheduling and advanced queuing. You don't want to use the default scheduler. Kubernetes allows you to clip that in. Heterogeneous hardware and awareness. Every new generation of accelerator that comes out doesn't mean you overchange your whole platform. It just means you can utilize a new platform while utilizing the one that you've already known and trusted. So you have access to different GPUs, different CPUs, AI-aware devices, GPU family awareness, accelerator topology, NUMA-aware placement are all need to become first-class signals on the Kubernetes platform. Scaling. So we have scaling is on the right signal. So traditionally, Kubernetes scaled only on CPU and memory. Obviously, in the AI world, that is not enough. We need to scale on things like tokens per second, queue depth, GPU utilization, and actually release the accelerators when idle. And finally, durable state. So in the agentic world, obviously we need state, and also the training world. So Kubernetes was designed for stateless services. So we have to build in AI a set of caching and a set of storage services for long-running training jobs, for agentic workloads to survive evictions, drains, topology changes, or even spot interruption if you're running on spot devices. So Kubernetes gives you the foundation, but what we're going to build on upon here is the rest of the session is what we layer on top of Kubernetes. Okay, so I gave you the why. Now we're going to get the what and the how, okay? So let's get concrete here. We're going to walk through a 4-layer stack and go through each layer of the stack. Each has its own tools that I'm going to suggest, trade-offs, and we actually have some announcements. So excited to get through them as well. Okay, so this is the mental model for the rest of this session, going from the bottom up, Kubernetes up. The bottom we have Kubernetes, where we have the substrate with Kubernetes and AKS, Azure Kubernetes Service. On top of that, we're going to go through inference and serving, which I find most customers start with. It's the way to get some value out of AI, or at least see what AI can provide for you. So we're going to look at inference and serving with 𝗦𝗲𝗀 and AI Runway. Then we're going to move up the stack into the green, training and fine-tuning with 𝗦𝗲𝗀 and AnyScale on Azure. The demo there is really cool, so I'm excited to show you some really cool training and fine-tuning that we can do very quickly. And at the top of the stack, the area I'm having a lot of fun with at the moment is the agentic orchestration. So we're going to look at skills, MCP, and OpenClaw, and some things we can build together. So we're going to start with inference, and then I'm going to go to the top of the stack, and then finish with the substrate at the bottom at the end. Okay. So let's take a look at inference and serving layer. And as I said, I want to start here because if you haven't started your journey, some folks are running Kubernetes, but not AI on Kubernetes, right? So I think this is the logical starting point. And I'll tell you why that is, because you have a model you want to run up, and you want to run it up in production, you want to run it up in dev, you want to get started and see the value AI can provide and have your developers start to integrate that model into a workload. So let's talk about what that looks like on Kubernetes. All right, so what we're going to talk about here is two different open source tools, so you can pick them up. They're all on GitHub today. Don't worry, I'll get you the links, with one goal. So the goal here is to get a model, an inference model, serving reliably. So you get an endpoint that you can make an inference request to, right? So let's start on the left in the blue. We have the platform layer with AI Runway. What AI Runway provides is a Kubernetes native inference platform with a web UI and a unified model deployment controller. So what this actually means to you is you can get a model up and running on Kubernetes very quickly with just a few clicks of a button, and I will show you in a demo in a couple of slides later. And it supports all the major engines out there like VLLM, SGLang, TensorRT, Llama CPP. So you can plug your own serving engine in. There are many different serving engines with different trade-offs. This allows you the flexibility, but it has one-click deploy with a nice UI where you can run this up this afternoon on any cluster and get started. And then over on the right, we're going to look at the Kubernetes AI tool, excuse me, tool chain operator, or 𝗦𝗀𝗀 for short. It's the operation layer. So this takes care of all the operational burden that you need to run a model and serve a model in production. It has optimized presets for pipelines, data, and tensor parallelism. And it has KV cache, so key value cache aware routing using Kubernetes primitives like Inference Pool. The important relationship here is that the AI Runway is the platform, and 𝗦𝗀𝗀 is one of its providers, alongside things like NVIDIA, Dynamo, KubeRay, and LLMD. And the great thing about this, these are all open source. They're both Kubernetes native, which means you can run them on any platform. You can pick them up and run them on any Kubernetes cluster that's compliant today, and you can run them anywhere. All right. So I'm going to walk you through kind of the experience that you're going to see on the next slide where I go through the demo. This is what you're going to go from. So the promise here is from browsing a model to serving in production in just a few clicks, right? And primitives you already operate. So if you're running Kubernetes today and you have your workloads or your app workloads already running on there, you're using the same tooling. So we're going to browse and deploy. For step one, we're going to browse. We're going to go to AI Runway. We're going to pick a model from the model catalog, which integrates into the Hugging Face UI, where you can go to all the latest models, open source, open weight models as well. You're going to check the GPU fit, so it's actually going to say this will fit on your cluster, or it'll trigger some auto scaling on your cluster to make it fit, and then create a model deployment. Step two, we're going to actually create a 𝗦𝗀𝗀 workspace, which estimates the GPU utilization that's required, the auto scaling, so the nodes that you need, and estimates where you'll actually run this workload and takes care of all of that with optimized presets. And boom, it spins up an endpoint which is live. And then finally, you just ship that off, and Kubernetes does the rest from 𝗦𝗀𝗀, which offers auto scaling. We integrate with VLLM metrics, so you can scale on all different metrics. We have canary deployments for rollback. We have rollback-aware deployments as well. So every piece on the right side of this slide is a Kubernetes primitive that you already know how to run and operate. We're not giving you anything new. We're just shaping it for AI. So we have all the primitives down at play on the bottom. And I believe the next slide is demo, okay? So I've got to give you the setup and the quick drum roll. This was filmed by a colleague of mine named Ralph. I like to talk over demos, but Ralph has a voice for radio. It's smooth and buttery, so you should enjoy it. Let's see, and Ralph's going to take us through AI Runway. Enjoy.
Let's look at the user experience of AI Runway. This is the model catalog, the first thing your data scientists and developers see. Think of it as your app store for AI models. We have a curated set of popular models, 𝗀, 𝗲, DeepSeek, llama, each with a quick summary, how big it is, what engines it supports, and what it's good at, chat, text generation, multimodal, and so on. But the real magic is this GPU fit indicator on every card. It tells you instantly whether a model will actually run on your cluster. No guesswork, no trial and error. Before we deploy something, let's also take a quick look at the Runtime tab, where you see the inference frameworks that run your models under the hood. AI Runway supports multiple runtimes, and it's entirely extensible, so you can choose a different runtime when you want. You're never locked in. Let's go to the Hugging Face gallery and search for DeepSeek R1, 671 billion parameters. This is not going to fit on our single node, which has 8 H100s. So I then go into Deploy, and I select Dynamo as the runtime. We'll deploy into the default namespace and continue down the options. As you can see here, because this model is so large and one node was insufficient, it is recommending 3 nodes that will have 24 GPUs in total. And because the autoscaler is enabled on this cluster, when we deploy, we will eventually receive the extra nodes that we need. Now here's where storage volumes come in. I'm attaching a persistent volume backed by Azure Managed Lustre. This is a high-performance shared file system. The model weights get cached here, so on restarts or scale-out, the new nodes don't have to re-download hundreds of gigabytes. It's read-write many, so all nodes can access it simultaneously. You can also see the cost estimate updating in real time. We have a good idea exactly what this deployment costs per hour and per month on Azure. This value will of course depend upon your cloud provider. So here's where it gets interesting. Right now, our cluster only has a single H100 node, 8 GPUs. But DeepSeek R1 needs 24 GPUs across 3 nodes. So what happens when I hit deploy? We'll skip ahead here since autoscaling takes a few minutes, but once those nodes come online, the deployment rolls out across all 3 nodes and goes to running. Now that DeepSeek R1 is running, let's use it. In the deployment page, we can see our storage and the mounted disk, and you can see the gateway endpoint. AI Runway integrates with the Gateway API inference extension using Istio in this case. This gives us a single stable endpoint for all our models. There's also a ready-to-use curl command. It's a standard OpenAI compatible API. Any tool or SDK that speaks OpenAI can talk to your models without modification.
Excellent. Do you agree? I think Ralph has a career in audiobooks. I can definitely listen to his voice. Smooth and buttery, right? So that is the power of AI Runway. Ralph went through that in 3 minutes, what used to take me 3 weeks to get up and running. So the fact that you can click through, get everything provisioned using an open source tool that's available on GitHub today is absolutely powerful. Okay, we're going to move up the stack now. We're going to go to training and fine-tuning. You've got your model, you've got it up and running. Now you want to fine-tune it with your own data for your own workload, okay? Let's have a look at 𝗲 and AnyScale on Azure. Okay, so now we want to talk about what 𝗲 actually gives you and what it powers. So eventually, all the agents need you to have a fine-tuned model with your own data behind it. So 𝗲 is the workload that actually powers that. So AKS on its own provides the pod scheduling, the auto-scaling, the node lifecycle, networking storage. It provides the substrate, as I mentioned. It's hardened for production at scale, but production AI also needs things AKS doesn't provide natively. So we need a distributed compute and scheduling framework that schedules both the CPUs and GPUs in a single job. We also have heterogeneous hardware. 𝗲 takes care of that with fractional GPU allocation, which is actually really important if you want to keep those GPUs at 100% as long as possible. Multi-node orchestration for both training and reinforcement learning. So this becomes a CI/CD pipeline for your models, reinforcement learning. auto-scaling, so it takes care of auto-scaling on your behalf. And the really cool thing that I'm going to show in the demo is it's one Python native API across data prep, training, tuning, and serving. And that's really cool. It's all hosted in their interface, and you can deploy from their interface and actually run it on an AKS cluster. So that's the gap that 𝗲𝗲 fills. AKS is the cluster, 𝗲𝗲 is the workload, and we're going to take a look at how 𝗲𝗲 can help us with training and fine-tuning. So today, I'm announcing the public preview of AnyScale on 𝗲𝗲. So this is Managed 𝗲𝗲, which is an Azure native integration in collaboration with the folks from AnyScale. So it's in public preview. The AnyScale runtime runs inside your AKS environment and is integrated into your Azure control plane. It's open source 𝗲𝗲 is the distributed compute engine. AnyScale provides a managed lifecycle, observability, and 24/7 support. It runs in your subscription. This is super critical, and I'll talk about how it's actually configured in your subscription. Build through your Azure agreement, which is really cool because you don't need to go form a new vendor relationship. You just pay us, and we make sure we work with AnyScale as well. So this is how that looks, how it's delivered, because I think it's important to separate how it actually runs on your architecture when you're worried about sovereignty and when your data is. So there's two boundaries that matter in this architecture. We have them boxed, one in the orange at the top and the blue at the bottom. So the AnyScale control plane is along the top. It runs in the AnyScale managed Azure tenant, which includes dev tools, observability, APIs, controllers, job orchestration, monitoring, and many more things. And in your subscription, which is the bottom, that's where your data and model lives. So this is great. You don't have to send them anywhere else. The AnyScale runtime runs a managed 𝗲𝗲 operator on your AKS cluster with your blob storage and your GPU and CPU nodes. So the connection between them, everything stays within your tenant and your realm. So the three pillars worth calling out, which we have along the bottom there, provisioning from the Azure portal, one portal. You don't have to go to multiple portals. Same workflow for your team that you already know and love, unified billing, which I mentioned, and the very best part of it is enterprise security with Entra ID, because not only do you get workload identity, you get identity with your own credentials, RBAC, audit, and all the trails and compliance trails that you already know and love. So your data and your model never leaves the environment here. So next demo is coming up right now. I'm actually going to speak over it. But I do have my colleague in the front, Bob, who helped me with this demo, so you get to feel free to critique me. I'm going to move to the side as I talk over this. We're going to start in the Azure portal, and I'm going to show you the full thing, and we're going to go through a complete training and fine-tuning exercise with a product catalog search. Buckle up, it's a 7-minute demo, and it's going to be pretty quick. So we start, as I mentioned, it's all integrated in the Azure portal. We're in the Azure portal here. We don't have to go anywhere else. And from the Azure portal, we can go to the search bar in the top and the middle and go ahead and type AnyScale. AnyScale will appear. It's in preview here, so it should show up AnyScale Cloud. You can click AnyScale Cloud. The list of AnyScale Clouds will come up. Of course, we're going to create a new one here, so let's go ahead and go through the create flow. The create flow is going to be very familiar to folks familiar with Azure. So what subscription would you like it in? We're putting it in that tab subscription. What resource group? You can either create a new one. We're going to use Bob's testing for our resource group. And where are we going to put it? We're going to go put it in South Central US. We give it a cloud name. This is to identify the cloud that we're talking with and the connection with the AnyScale control plane. And then we can provision either a new cluster or a cluster that we already have. So if you already have Kubernetes clusters up and running on AKS, you can go ahead and link them in there. This is the cool part as well. We have managed identity. So this is how all the workloads running on the AnyScale cloud identify themselves with Azure and the storage accounts, which model checkpoints and weights are stored. And finally, we're going to be using ACR to store any container images, which support the 𝗲𝗲 operator, AnyScale operator. Okay, finally, we're going to run our checks and balances, run it through the template before we submit. So let's just take a little look to recap before we go ahead and click create here. So all the details there are verifiable, that we set it up with the resource groups in the test subscription. And what we can do then is go ahead and click create. We'll click create. And we'll wait for the, the elevator music to start while I grab a drink. And hopefully with the magic of video editing, this thing will create pretty quickly. We can see up there in the notification window that the submission is already taking place. And this thing should come up and running in just a matter of a few seconds. So I've gone from no AnyScale to an AnyScale on Azure cluster up and running in a matter of a few clicks. This is extremely powerful. And I haven't had to leave the Azure portal at all to make any of this happen. So we can see the deployment is initializing up there on the right, and now that that deployment's running, we should have a cloud instance up, and we can navigate to Bob's test, which we created, which was the name of the cloud. So here we see our resources. We see our resource blades on the left, familiar for anybody who's used the Azure portal. Nothing new here, but this is the instance of how it's created within the Azure APIs. We can click launch. This launches the AnyScale UI. The really cool thing here is you can continue with the same credentials that you log into the Azure portal. So we're going to demonstrate how that works. This is really powerful. One identity, multiple platforms, all tied in using the experience that starts in the portal. So we've gone ahead and authenticated. Now we've launched the portal here, and what we're going to do is walk through just a few things. This is where it's going to get quick, but we're going to get into it. We see some dashboards, workloads, Jupyter notebooks or workspaces workspaces, Jupyter notebooks where your AI developers or your data scientists work. We have jobs and services. Jobs are short-run jobs that run to completion, and services are how you present these to connect to for inferencing. So we're going to go into workspaces. The really cool thing is you can go from 0 to a full running pipeline here in just a minute using templates. So there is a bunch of baked-in templates to do anything from multimodal inferencing to LLMs to hero demos, but anything you can think of, there is a template library that AnyScale provides, and you can get access to up and running models and infrastructure in just a matter of clicks. So now we're going to look at one that we provisioned, and we're going to walk through that. Over here on the right of the screen, you can see that it's picked up that I have a cluster of CPUs only. I have a head node over here, and we can see that it's actually running on top of a Kubernetes cluster that I've already provisioned, which is the way I set it up, an 8-node cluster. And what we're going to do is show you something really powerful. So your AI developers or your data scientists can just launch the notebook from directly within the portal and start executing code. So here what we have is an embedded Visual Studio instance, Visual Studio Code instance, and we can start looking at the code. So what we're going to do here is actually run through a fine-tuning demo where we have a product catalog of images, and we're actually going to fine-tune that embedded model that we run today with a set of new images that we want it to make better recommendations. So if I type in shoe, it's going to recommend sock. If I search for headphones, it's going to give me things like speakers and other things that are related. So what you see here is all the Python code from within the notebook that can be run and executed directly. You don't have to leave this interface. You can simply click that play button there on the right and execute these bits and pieces. And what we're doing is actually cleaning the data right now and running a fine-tune. So you can see that little circle whizzing around there on the bottom. What it's actually telling us right now is I've run some fine-tuning, and the model's gone from 0.34 accuracy to 0.2 because I've given it new data to train that model and make it more specific to my work use case. And this is going to graph those results for me so that I can say I've actually made the model more accurate through the fine-tuning, which means I'm going to get better recommendations. I know this is going quickly. I'm trying to follow along here to keep you all up to date. And finally, we can actually look in the embedded vectors here for relationships. Everything in the green there are related items. So we have laptop stands, smartwatches, portable SSDs, webcams. The fine-tuning has actually created those relationships. And finally, we can see here these clouds. On the left, you see that the colors are all over the place, and on the right, they're aggregated, meaning that we've put all the references that are close together and made the model more accurate with the data we've provided. Now, finally, we're going to want to serve this somewhere. And the great thing about AnyScale on Azure is it takes care of the routing. We have 3 endpoints here, one for our HTTP ingress, and there's 2 models, one that does image to text, and the other one does the recommendations that we just fine-tuned. So around this movement here, we're actually showing that if I ask it about a pair of wireless headphones, it's going to give me some different references and the matches or the applicability of those references to those other items. So what we've done here is go from notebook to production with just a few clicks. Finally, I'm going to just show the integrated monitoring and observability stack, which is super powerful. So you can see all the utilization of the nodes in the clusters. You can actually have access to what's running and the dependencies, which is something that only the AnyScale platform running Ray gives you under the hood. So you can not only see what's running, but you can also troubleshoot and make sure your platform is being utilized to the extent that you want it. So super powerful platform, and in only 7 minutes, that took me 3 months to do, only 3 months to go, so it's great to see this in action, and I really think you'll all love it for your fine-tuning and reinforcement learning. So check out AnyScale on Azure with Ray under the hood running on AKS. And thank you, Bob, for that demo. All right, we're getting into the late stages here. We're going to finish on Agentic, talk about some customers, and I'm going to get you out of here. Okay, so wrapping up, this is the area that I'm really excited about. So we've looked at inferencing, serving, and we've looked at training. Last question is, how do I serve that all up to my autonomous agents? Aren't we talking about agents here? So I'm going to show you how to do that. So this is where agentic orchestration comes in. And this area, I will say, is arguably the least mature part of the stack. It's changing very rapidly. You hear OpenClaw, Hermes today, but I don't know where it's going. But the cool thing is you can run it up and start to experiment with it. So what we're going to do is just take a look at building an agent on Kubernetes with skills, MCP, and primitives that help. So if you've never heard the terminology of a skill, it's basically just a discrete set of capabilities that an agent can run. The cool thing about skills is it's any kind of script that any of your platform team would run. Everything that I had checked into a repo has now become a skill, and I have agents run it on my behalf. So think about that, hold that in your mind for day 2 operations. You register that in a catalog, and you can call it from any agent that has the right permissions to call it. MCP is a protocol that allows all models, all agents to talk with tools and data and other agents, so it allows the connectivity there. And one really cool thing is we actually exposed the AKS MCP server today. So if you want to run up a set of tools and interact with AKS in natural language, you can say, provision me an AKS cluster in VS Code with the AKS MCP server, and the LLM will make the call for you and actually provision the infrastructure. That's all open source today. It'll run all your tools under the hood, and we run with workload identity for protection. Then on the right, we have Kubernetes fill in the primitives where we have gaps. So we're using namespaces to isolate the agents, RBAC to make sure that it has the right privileges, and service meshes to make sure that we can observe and filter the calls and actually make policy changes that we need. So Kubernetes has all the primitives we need under the hood here to make this work. Okay. So this is where we're right out on the edge of the frontier here. I'm going to give you an example of how to do this. So talked about OpenClaw earlier today in many of these sessions, but it's a reference implementation for a multi-channel, multi-tool personal AI assistant. I use it to book my Pilates lessons. Hold your applause for later. There's no way I'm doing Pilates. Not because there's anything bad. I just don't know that my body will do it. It bridges a chat platform into a multi-agent orchestrator. So we're going to show a really cool demo on how to do that with approval flows, tools, and memory. It takes care of everything. It's a base pattern. And we have a use case that I'm going to show in a minute. We've actually codified a bunch of skills that our AKS engineers use to help with troubleshooting environmental issues with AKS. So think about it as we can create agents out of our support engineers and actually give them access to the right tools at the right time so they don't have to go through the monotony of pulling all the logs or making decisions. I'm going to talk about that in a minute, but we use that right now for day 2 operations, and that might be a great value add for you if you're starting to experiment with agents. And then finally on the right, we're actually releasing today an agent reference stack for Kubernetes. We call it KARS, K-A-R-S for short. But this gives you a vertically integrated, secure sandbox environment where you can actually apply workload identity policies and sandbox environments, leveraging Azure Linux under the hood, which is really cool. So you can rest assured that you have the right security primitives in place and don't let those agents run wild, because I know security is a massive concern. So let's take a look at this. This is a 2-minute demo. We're going to take a look at the agent reference stack for Kubernetes, which is under Azure/KARS. And you can run this up today, and then we're going to finish up. So just going through the repo here, you can see the agent reference stack for Kubernetes. And popping over to a terminal here, if you have any Kubernetes cluster, even one locally, you can just run it up with a single command. It ships with the binary. We can say KARS up. We're provisioning a demo. And what this is doing is actually running all the checks to make sure anything that I'm missing needs to be installed, but I'm actually running this locally against a cluster, an AKS cluster that I have in my environment. So I ran it up, what we're going to see here is in the portal, we can see the namespaces. We see that we provisioned a KARS-system KARS system namespace. That's where all the machinery is going to run on your AKS cluster. Right now, what I'm showing you is I want to run up an OpenClaw instance to start playing with OpenClaw using a custom resource in Kubernetes. So I'm saying, please, OpenClaw, be a helpful agent. Here's the access you have. Here's the tools you have. Here's what you can call. All declarative in Kubernetes. I'm going to apply that to the cluster now. And from here, we're going to be able to access the OpenClaw UI. We'll just have a look over here. I want to just plug an open source tool called Headlamp that gives you, it's a heads up display for Kubernetes clusters, and it actually has plugins. We've built a KARS plugin as well, so you can go to Headlamp, which is open source, run up and introspect what your sandbox are running, where your agents are running, what security capabilities they have, what policies you have in place, and what access they have. We also have a mesh topology, so you can actually see the mesh graph of where all the calls are going from your agents to your LLMs or elsewhere. Finally, we have a binary version of that as well that you can run up. If you go KARS/operator, you can see all the same things you see in the UI at a glance here to see what's running on your cluster and the security controls it has. So I'm running a KARS list now. You can see the sandboxes. I have a demo that I've run up here that's in a sandboxed environment, and now I'm going to ask to connect to it, and we will get the OpenClaw UI, which I can then log into. So this passes back the URL with the token embedded, and I can go ahead and log in. And one of the cool things is I've run this up in just a couple of minutes. This demo was not edited. It's all just there live. We get our chat interface. We can say hi. We start getting a response back from the agent here, and we're going to ask it something very timely. We recorded this yesterday. Can you tell me what announcements Microsoft had with NVIDIA this week? So it's going to go over just to show that it's very fresh and very live. This is the constraints it's working with. So it's actually going to go to the web and consult and give me a well thought out response based on the media and press analysis yesterday of what actually happened at build between NVIDIA and Microsoft. So you can see we've released these different things, and you can see that in a couple of minutes and a couple of clicks, I've got something I can give me value for my engineers to start playing with agents and the power of agents on top of AKS or Kubernetes. So that is the agent reference stack for Kubernetes. Okay. Now we're just going to wrap up and talk about some customers that are seeing some value. So here are the four reasons where Kubernetes is wise. Practitioners are building on top of Kubernetes for the agent layer. We have session state. We have multi-step coordination built in, tool call observability, and then finally a composable stack. I've harped on that composable stack, but you can pick up skills. Cloud providers publish MCP skills all the time, and you can interact with Azure using the AKS MCP server to interact with AKS using natural language. Okay. Substrate, and I'm getting low on time here, so I'm going to go through these announcements. So we've got a few announcements, 4 announcements today, spanning both single cluster, multi-cluster, and fleet, and we're going to walk through them. Okay, generally available, we have AKS Automatic. If you're using Automatic, it's the easiest way to get started with Kubernetes and AKS, but what we've done now is give you managed system node pools. So all the pods that need to run the Kubernetes components themselves, we now take care of managing that and scaling that. Why it matters for AI is you don't need to run those components on your GPU nodes that you want to milk every cycle out of to run your AI workload. So that's AKS Automatic with managed system node pools. GA today. Azure Container Linux, excited about this one. So we've given you the best of Azure and the best of Linux in Azure Container Linux. You get smaller attack surface area. We've curated the level of packages, smaller CVEs, and predictable fast patching cycles. We have transparent supply chains, so we package everything up, distributed it to the nodes so that you get predictable signed artifacts, predictable upgrade paths for regulated workloads, and then consistency across hosts. You can start this up for both in a container environment, on your VMs, or even in WSL on your Windows machine as well. So we believe the OS layer in AKS should be invisible, secure by default, and consistent and out of your way. Okay, really excited about the public preview of AKS on bare metal. So this is direct hardware access from AKS to manage physical nodes right? So we can actually install AKS on physical hardware with no hypervisor, so no virtualization layer for your workload, which is important for GPUs, NICs, and all the like of the specialized accelerated hardware. Same AKS control plane, different operational model, same operational model, sorry. And it matters for AI because you can extend AI to on-prem, other clouds, and have it inside Azure, and not pay the virtualization tax for your on-prem environment. So it allows you to scale very quickly. And finally, I'm really excited about this one. Clusters get really, really big really quickly. So you want to be able to be in a position where you can manage the fleet of clusters. Fleet for Arc-enabled clusters allows you to have progressive rollouts across clusters, intelligent workload placement for your workloads across different boundaries, environments, on-prem and on the edge. Consistent policy enforcement, so we're pushing the same policies to all environments at the same time, and it's Arc-enabled, so it's in the Azure, it has an identity in Azure, using the same control plane. So all AI workloads outgrow a single cluster very quickly, and this is how you stay ahead of that. Okay, so back to the full chooser. We've run the whole thing. I'm just going to finish up with 2 customers. I need just an extra 2 minutes here. I got too excited. So what this looks like in production, we're going to show you a couple of customer use cases. We actually have Royal Bank of Canada here who are leveraging 𝗦𝗲𝗀𝗀𝗃 in production. Their platform onboarding and deployment operator wraps the GPU resource provisioning into a CI/CD workflow that the developers run themselves. So it's a self-service deployment and it's secure by default. 𝗦𝗃𝗀𝗀𝗃 is used for the production model serving, workspace and AI models deployed as pods, and the model images are stored in the bank's ACR, which is Azure Container Registry. So the really important thing is we have a compliance perimeter. This is a bank, obviously, and they're utilizing things like Entra ID, Key Vault, private ACR, and their models are all their data stays inside their secure perimeter, their subscription and their boundary. And this is a really great example of how banks are utilizing tools like AKS on top of 𝗦𝗃𝗀𝗀𝗃 on top of AKS for model serving. Okay, one more before I finish up. This is really cool. Wave is rewriting the self-driving playbook with end-to-end deep learning, and they're running that on AKS with Ray. So their driver, the AI driver actually demonstrated autonomous driving in Tokyo only after 4 months. I lived in Japan for 4 years, and I still couldn't drive in Tokyo. So that beat me out. So with a brand new Nissan vehicle, they demonstrated learning on the go. So that kind of generalization required massive infrastructure and clusters, and they use AKS and AnyScale on Azure to connect thousands of GPUs into a flexible supercomputer for training and validation. And this training layer is pushed to its limits. The scale of the infrastructure directly determines how quickly they can iterate and train the model. So this is a really cool. Okay. Finally, I wanted to talk about AKS Claw. So I mentioned earlier, I've got an example of agentic workloads on top of AKS. We have AKS Claw. AKS Claw is our SME, so our subject matter expertise, our SREs, encoded as an agent. And what this really allows is each dedicated engineer gets a dedicated instance with an isolated instance of Claw. The AKS Claw gets installed, and every new on-call engineer is able to be up and running within minutes with very minimal training and get the tools they need and access to the environments they need to make a decision to get our customers back online. So this is one natural language interface, but we can replicate consistent operational behavior by encoding it in agents with something like AKS Claw. So very excited to be able to build on top of the primitives that I've shared here today. Okay, so now what? This is what you've got to take away with. Start with Kubernetes, right? That's a substrate that many of you are already using today. Build the agent layer with MCP skills and reference stacks like OpenClaw. Choose the tooling that matches your build versus buy. If you want things like AI Runway, 𝗦𝗃𝗀𝗀𝗃, we have a tool for every layer of the stack. You get to mix and match and choose. We got some tools, obviously, for inferencing and serving Kato and AI Runway. We have Ray with AnyScale on Azure, and then we have what I announced earlier for runtime specialization for agentic AI workloads. And then finally, fleet. So invest in fleet early. I'm getting the look when your workloads outgrow a single cluster. Okay. I think that gets us to the end. So I really appreciate your time. If you have any feedback, good, bad, or otherwise, I'd appreciate you taking the survey. But I'll see you all around. I'll be over here for the next day or so. If any of that inspired any curiosity, I'd love to chat with you all about it, and I'd love to learn from you as well, see what you're building, and hopefully next time you're on stage telling me what you'll build. That brings me a lot of excitement to see what you'll build. So thank you. Have a great build. Thanks for giving me an extra couple minutes. Appreciate the time.